So in this question we've got an arithmetic sequence and all we're given is the 17th term is 150. The 20th term is 177. Can we find, 1, define the sequence, number 2, find the 35th value, 3, is 552 in this sequence, and part 4, the first term, which is over 1000. So what we're given is this values here. 17th term is 150, 20th term is 177. So what we know is that each term, if we can define it as the letter U, UN, so that's the nth term, equals A. A is the starting value, and plus n minus 1, so that's the number in the sequence, times the difference, which is D. Okay, so if we use this, maybe we can define the sequence from that. So we're given the 17th term is 150. So we know the 150 equals A plus, because we don't know what the first term is, n minus 1. Well, we know n minus 1 is 16, and that's D. So multiply that by D. Okay, now the next one we've got is the 20th term is 177. So 177 equals, well again, we still don't know the first term, so we just keep that as A. And then n minus 1, well, as it's the 20th, n will become 19, and then that's D. Okay, so now we've got two equations. Now we can solve for either the A or the D from this. Now as A's are both equal, if we subtract one from the other, we can get a solution and hopefully find the D. So if I call this equation 1 and this equation 2. Now as the 19D is bigger than obviously 16D, I'm going to subtract 2 from 1. So if I do 2 minus 1. Okay, so let's set that up. So 177 equals A plus 19D. 150 equals A plus 16D. Okay, now let's subtract the 2. 177 minus 150, that gives me 27. A minus A, that cancels out. And 19D minus 16D gives me 3D. So 27 equals 3D. Divide both sides by 3. Then I will have D equals 9. So that's my difference. But I still don't know my A. So what I can do is, my difference is 9. I can plug that into one of these two equations and then get A. So let's use equation 1. So let's write it out again. A plus 16D. So D is 9. So 150 equals A plus 16 times 9. 9 16s are 144. So 150 equals A plus 144. Minus 144 by both sides. Do the same on here. 150 minus 144 will give me 6. And obviously this will cancel out, so I'm just left with A. So A is 6 and D is 9. So to define the sequence, I can write UN equals 6 plus n minus 1 D. So n minus 1 times 9. So plus 9 times n minus 1. So that's my first solution to part 1. So part 2, find the 35th value. So, okay, let's box these off. Now what I'll do now is plug in 35 into this value with part 1, so we can use that. So UN equals 6 plus n minus 1 times D, which is 9. So I'll just put the 9 there, that's fine. So we want the 35th, so therefore U of 35 is 6 plus 35 minus 1 times 9. So now let's bring this down here. So now we've got 6 plus 34 times 9. 34 times 9 will give me 306. So it equals 6 plus 306. 6 plus 306 will give me 312. So that will be 312. Next we want to know, is 552 in the sequence? So let's clear some space off the board and go for part 3. Okay, so is 552 in this sequence? So what we'll do is we'll do a check. So 552, let's use this calculation here from part 1. So let's do it here. UN equals 6 plus 9 times n minus 1. So is 552 in this sequence? Let's plug 552 in here. So 552 should equal 6 plus n minus 1. 9n minus 1. Okay, so what we want to do here now is to see if the solution to this yields an integer for the value n. So let's multiply out this bracket and let's move on from there. So 6 plus 9n minus 9. So that's 552. Okay, so we've got a 6 and a minus 9. That makes minus 3. So let's make that our next line of working. So we've got 9n minus 3. So now add 3 to both sides. Try and get 9n on its own. So now 555 equals 9n. Okay, let's see if 9 goes into 555. So that will yield, this side will cancel out. 9's into 555. Well, 6 9's are 54. So that gives me 6. Remainder 1. 9's into 15 go 1. And with 2/3 left over. So as this is not an integer, therefore this is not in the sequence. Is 552 in the sequence? The answer is no. That's not, by virtue of n not being an integer. Right, now let's find the first term over 1000. So what we're looking for now, use this formula again. So UN equals 6 plus 9 times n minus 1. So we need a value of n where the value here will be over 1000. So what we want to do is now is set 1000 is less than 6 plus n minus 1. So 9n minus 1. Now, first term over 1000. So 1000 is not included. So it's a strictly, the 1000 must be less than the value on the right hand side. Okay, let's expand out that bracket. 6 plus 9n minus 9. Same as what we did on this side. Now we've got 6 and minus 9 as we have here. So 1000 is less than 9n minus 3. So add 3 to both sides. So 1003 is less than 9n. Okay, so now we're going to go careful here. We need to divide by 9. So divide both sides by 9, and then we'll get n is greater than, so 9's into 10, that goes 1, carry 1. 9's into 10 go 1 again, carry another 1. 9's into 13 go 1, and a little bit, which will be 4/9. Okay, so now, as this is 111 and 4/9, obviously 111 and 4/9 is not in a series, in a sequence, so therefore 112 will be the first term. So 112, so 112 will be the first term over 1000. So if I plug in 112 into here, just do a little quick check. Just do that in a little box here. 112. So U of 112 is 6 plus 9 times 112 minus 1. Okay, let's multiply this one out. 6 plus 9 times 112. Well, 900s are 900 and 9 12s are 108. So that's 1008. And then subtract 9. Okay, so 6 plus 1008 minus 9. So 1008 minus 9 is 999. plus 6 is 1005. And there we go, that's proof of our answer. Okay.